Let's now understand the need for a validation sample. Typically, your original data, you are going to be splitting it into training, validation, and test. Let's understand the need for having a validation sample. Now, let's suppose we already split the data, split the raw data into training, validation, and test. Let this be 60%, 20%, 20%. Now, till now, what we have been discussing is we will train one machine learning model on this training sample, training data, then test the performance of that model on the test data. In case we did not split it like 60, 20, 20, in case we split it into 80 and 20, 80 train and 20 test, 80 percentage train and 20 percentage test. If this was the case and we built only one machine learning model, then that is what we would typically do. Now, in practice, what typically happens is instead of training just one single machine learning model, we will be training a lot of different machine learning models. Let's imagine machine learning model M1, M2, M3, so on and so forth, say till M10. Let's assume we trained 10 different models. Some of these models, this could be a linear regression, this could be, say, a decision tree, various different algorithms we are using, and sometimes this could be a variation of the decision tree itself. These two could be from the same algorithm, but a different variation of that algorithm. All right. Like that, you can build a lot of different models, not just one single model. Correct. Now we have trained a lot of models. What we will do is the purpose of having a validation is amongst these 10 different models, we want to find the model that is the champion, that is the best performing. After finding the best performing model, we want to add one more layer of security, one more layer of check, and we want to ensure this model that we selected here in this step, validation step, performs equally well in a test step. Two different unknown data. If our choice of the champion is correct, this champion should remain the champion in test set also. This should the same model. Let's suppose M2 was the champion in validation. The same M2 should be performing as good as it did in validation. That's the idea. Now, let's imagine what could have happened if we did not have this validation set. Let's imagine we had just the training set and the test set. 80% be training data set, and 20% be testing data set. And we have models from M1, M2, so on till M10. We have trained all these models. Now, amongst these 10 different models, let's say M2 came out to be the best model in test data set. This M2 gave the best performance. Now, what is the guarantee that M2 will be performing equally well? We are not validating this, right? What if we have new data that's not from the test data? This is, we already know the actual Y. Now, what if new data comes and in this new data, we have no idea that we have no guarantee that M2 will be the best performing model. We haven't checked that. It could be the case that M3 might be best performing here. This could very well happen. And this actually happens quite frequently in data science projects. And that is why we want to be as rigorous as possible whenever it comes to validating or testing your machine learning models itself. And that's exactly where the concept of having a validation data set, especially when you are training a lot of different machine learning models. When that happens, your validation data set has a lot more relevance and is actually a necessary step in most different projects that you will come across.